Beginners Math 9. Today we are going to do 6.2 Part 1 notes, which is called Solving a System by Substitution. Alright, these notes are going to be nice and quick. We're going to do solving a system of equations by substitution. So far we have solved the system by graphing. Graphing is nice, but the downfall is not all systems intersect at nice coordinate points such as 2, 4. Sometimes they are fractions, and this is where substitution totally comes into place. So our first one, y equals 3x and x plus y is equal to negative 32. That's our system. When you solve by substitution, you always want to get one of the letters in either one of the equations by itself. In this case, this y is already by itself. Okay, so what we can do, we can take the y out in the second equation and plug in the 3x in its place. And remember, whenever you do substitution, you always have to put parentheses around it. So we have x plus, instead of the y, since y is equal to 3x, we're going to plug that in its place. And that's equal to negative 32. Now we're going to solve for x. X plus 3x is 4x is equal to negative 32. We can divide both sides by 4, and x is equal to negative 8. Awesome, if x is equal to negative 8, we can plug that into the other equation that has y by itself. 3 times negative 8, and you get y is equal to negative 24. Again, remembering to always write your answer as a coordinate point, negative 8, negative 24. Awesome. For our next example, example 2, you'll notice our problem here is that we don't have a letter by itself. But I noticed that the leading coefficient of this y is a 1, so I'm going to add 2x to both sides. So now we have y, that's a terrible y is equal to 2x minus 3. Now that we know what y is equal to, in the first equation, wherever there's a y, I'm going to plug in a 2x minus 3 in its place. So 2x minus 3 plus 4x is equal to 14. Awesome. Now we're going to have to do the distributive property. 6x minus 9 plus 4x is equal to 14. I'm going to combine like terms. 10x minus 9 is equal to 14. Add 9 to both sides. 10x is equal to 23. So x is equal to 23 over 10. Again, you would not be able to identify this x value easily on a xy coordinate plane because 2.3 is very hard to precisely graph on a piece of paper. Awesome, so now let's plug that in for y. If we have this equation y equals 2x minus 3, we're going to plug this into that equation for x. Y is equal to 2 times 23 over 10 minus 3. And when you do that, you're going to get 8 over 5. Good. So our answer is 23 over 10, comma, 8 over 5. Perfect. And again, because you're getting these one solutions, you can double check. If you plug this value in for x here and this value in for y here, you get 14. When you plug this in for x and this in for y, if you don't get 3, you made a mistake, but you do get a true solution for both of them. So both of those work. In both of those previous examples, if we were to graph them, both of those lines would cross and intersect at one point. Remember, when we graph lines, we can also have parallel lines, meaning no solution, or they can be ending up graphed the same line to be infinitely many. So let's see what's going to happen here. Y equals 3x minus 11, and y minus 3x is equal to negative 13. This y is already by itself, so I'm going to plug this in for y over here into this other equation. 3x minus 11. Remember, when you do substitution, you take something else and plug it the same thing in what it's equal to in its place. Minus 3x is equal to negative 13. You don't need these parentheses, so 3x minus 3x, those cancel, so I'm left with negative 11 is equal to negative 13. This is a false statement, so this is no solution. What this means is that these two lines, if you were to graph them, are parallel. You might be able to already guess where this one's going from, but that's okay. Let's see what happens. So in our past 3 examples, we got y by itself. I want to show you that it's okay to get x by itself and plug that in for x. So I'm going to take x out of this equation and plug that in its place. So we have 3.5 times negative 2y plus 4 plus 7y is equal to 14. After we do the distributive property, we have negative 7y plus 14 plus 7y is equal to 14. This 7y and this 7y cancel, and we're left with 14 is equal to 14. Since that's a true statement, it's infinitely many solutions. Again, what that means is, if we were to graph this line and this line, they would end up being the same. Perfect. Nice job today.